In this lesson, we will develop a method for integrating complex expressions by breaking them down into simpler expressions using partial fractions. Now, the concept of breaking down a complex expression into partial fractions is known to you from an earlier algebra class. Well, if you are not familiar with it, let me just refresh your memory. Now, let me start with a simpler expression, say like this. Now, how do you simplify an expression of the form 3 divided by x plus 2 minus 5 over x minus 5? Well, obviously the method is taking the common denominator and simplify. What is the common denominator here? X plus 2 times x minus 5. Alright, take the common denominator and simplify. When you do that, x minus 2, x plus 2 times x minus 5 becomes the common denominator. That means 3 will get multiplied by x minus 5, and minus 5 will get multiplied by x plus 2 on the numerator, giving you this. So it'll be 3 times x minus 5 minus 5 times x plus 2 all over x plus 2 times x minus 5, and that simplifies to, just expand them, negative 2x minus 20 all over x plus 2 times x minus 5. Now, this is the result of, say, simplifying this expression. Now, when you look at this, this is actually a complex expression. If I ask you to integrate it, it'll be very tough to integrate it in this form. But if you can break this down into this form, you can see these are made up of two simpler forms, and both can be integrated. Is that right? Integral f of x minus g of x, both functions can be integrated. So an expression of this form can be broken down into simpler expressions like this. And that is what is involved in the method of partial fractions. So how do you begin? In the method of partial fractions, we attempt to break down complex expressions like this into separate forms or separate fractions like this. So, to begin with, what we will say is, let this complex expression be equal to a over x plus 2 plus b over x minus 2. Now, once we do this, all we need to do is obtain the values of a and b so that the expression on the left can be broken down into these two simpler forms. Alright, so while the left side of this expression is difficult to integrate, we can integrate the right side of the expression. Alright, now let me review one more time some of the forms that we can write into partial fractions. Some forms of difficult integrals can be made simpler by breaking them down into partial fractions. Now, we will use some simple rules in order to break down a complex expression into the sum of simple expressions like f of x plus g of x form. Alright, the first thing to do is factor the denominator if it is not already in the factored form. Now, if the denominator contains two linear factors, then break it into two partial fractions using constants a and b, as I just illustrated, something like this. Negative 2x minus 20 over x plus 2 times x minus 5 can be written as a over x plus 2 plus b over x minus 2. And what is the criteria so that we can write it like this? The criteria is the denominator must contain the product of two linear factors. X plus 2 is a linear factor, x minus 5 is a linear factor. I suppose you know what that means. Now, you can do this only if the denominator contains linear factors. Now, what will you do if there is a third linear factor? If there is a third linear factor, then we'll go on to say c over that factor. Okay. Now, if the denominator contains some power of a linear factor, like x plus 2 to the power of 2, then we break it down into partial fractions like this. Watch how this is done. Now, here we have the third power of x plus 2 there. Now, you can argue that, but can't we write it x plus 2 times x plus 2 times x plus 2 and follow this method? No, you cannot. You got to follow a different route here. So, if the denominator is some power of a linear factor, then your right side will be a over x plus 2 plus b over x minus 2 to the power of 2 plus c over x minus. Now, this has to be changed into x plus 2. That's right. So, once again, if the denominator contains some power of a linear factor, we would go in a progression like this. The first term will be a over x plus 2. The next one will be a over x plus 2 to the power of 2 plus c over x plus 2 to the power of 3. You got to go in that progression for the denominators. If it is x plus 2 to the power of 4, we will add one more term. It will be d over x plus 2 to the power of 4. And we develop a method of finding that constants a, b, c, d, and so on. Alright, so we got 3 rules. There is one more that will be important for us. If the denominator contains a quadratic factor, like x squared minus 5, or 2x squared plus 1, then we break it down into partial fractions like this. For example, if you have the denominator as x plus 2 times x squared plus 1. Now, x plus 2 is the linear factor, and that will be taken care of a over x plus 2. But the next factor is a quadratic factor, x squared plus 1. Now, look at the way it is being taken care of. It is bx plus c over x squared plus 1. That's the way we take care of a quadratic factor. So, basically, if the denominator contains the product of linear factors, you have the right side as a over the first factor, plus b over the second factor, plus c over the third factor, and so on. If the denominator is some power of a linear factor, then you go in a certain progression like a over x plus 2 plus b over x plus 2 to the power of 2 plus c over x plus 2 to the power of 3, and so on. And finally, if the denominator has a quadratic factor, you got to treat that quadratic factor like this, bx plus c over x squared plus 1. Alright, let's use these to reduce some expressions in partial fractions. Let's do this. Obtain the partial fraction decomposition for x minus 2 over x squared plus 4x plus 3. Alright, one look tells you that the denominator is not factored, but you should say, but isn't this not a quadratic factor? Can't we use the quadratic factor form? No, that can be done only if you cannot factor the denominator any further. The first thing to look for is, can you factor this? What do you think? Yes, because look at the middle term. Middle term is 4x. Now, if you factor it as x plus 3 times x plus 1, I'm sure you are well versed in the art of factoring. You can factor this into 2 linear factors. That's right. This will be x minus 2 over x plus 3 over x plus 1. Now, this makes it simple. Now, how do you write this now in order to break it down into partial fractions? You must write this as a over x plus 3 plus b over x plus 1. So, because the denominator contains two linear factors, we write it as x minus 2 over x plus 3 times x plus 1 equal to a over x plus 3 plus b over x plus 1. Now, can you simplify the right-hand side by taking the common denominator? What's the common denominator there? The common denominator is x plus 3 times x plus 1. When you take this as the common denominator, see here, a will get multiplied by x plus 1 and b will get multiplied by x plus 3. Alright, let's do that. That will be a times x plus 1 plus b times x plus 3 all over x plus 3 times x plus 1. Now, you have an interesting phenomenon here. This is the left-hand side we are trying to simplify. And by using the constants, this is our right-hand side, which simplified to this. And if you look at the left-hand side and the right-hand side, the denominators are exactly the same. Now, what that means is the numerator of the left-hand side must be equal to the numerator of the right-hand side. Don't you think so? Yes, because that is the property of equality. If the denominators are equal, the numerators have to be equal. And therefore, we set the numerator of the left-hand side equal to the numerator of the right-hand side. X minus 2 equal to a times x plus 1 plus b times x plus 3. Now remember, this is an equation, or it is an identity. In other words, this is true for all values of x. If you put x equal to 0, x equal to 1, x equal to 2, it must be true for all values of x. And so, we can actually use a very clever method. What's our aim? Our aim is to find the values of a and b. Now, we choose an appropriate value of x. Now remember, we can choose any value of x because this is an equation that contains x on the left and the right. This is actually an identity. That means it is true for all values of x. So we choose an appropriate value of x so that one of the constants will be reduced to 0 and we can find the other constant. Alright, so this is an identity, not really an equation. It's an identity. But what's the difference between an equation and an identity? An equation is true for only 1 or 2 or 3, depending on the type of equation or values of the variable. An identity is an expression that is true for all values of the variable. This is an identity. Therefore, it is valid for all values of x. So we choose a value of x that will eliminate either a or b on the right-hand side. Tell me, what is the value of x that will eliminate a? Will eliminate this term. This term will become 0 when x equal to -1, isn't it? When x equal to -1, -1 plus 1 is 0, 0 times a equals 0. That term gets eliminated. And how will you eliminate this term? By setting x equal to -3. That's right. So, what value of x will eliminate a? We just found out that this term containing a can be eliminated by choosing x equal to -1. So when x equal to -1, a times x plus 1 reduces to 0. So let's use x equal to -1 in this identity. Everywhere you find x, replace it by -1. That gives you -1 minus 2 equal to a times -1 plus 1 plus b times -1 plus 3. Now that will eliminate a. It'll give you negative 3 equal to 0 plus 2b, negative 1 plus 3 times b. And therefore, we have the value of b. 2b equal to negative 3 or b equal to negative 3 halves is the value of b. Alright, now let's eliminate b by setting this x equal to negative 3. That gives you, replace x all over by negative 3. Negative 3 minus 2 equal to a times negative 3 plus 1 plus b times negative 3 plus 3. That will eliminate this term, giving you negative 5 equal to negative 3 plus 1 is negative 2. Negative 2a, or 2a equal to 5 gives you a equal to 5 over 2. So we will go to our expression. Look at the right hand side. I have that expression there. Our expression is a over x plus 3 plus b over x plus 1. This a gets replaced by 5 over 2. And b gets replaced by negative 3 over 2. So what will this become? When a gets replaced by 5 over 2, this will become 5 on the numerator and 2 times x plus 3 on the denominator. Is that right? Then b is negative, we'll make this sign negative, and the numerator will be 3 and the denominator will be 2 times x plus 1. So we have x minus 2 over x plus 3 times x plus 1 is a over x plus 3 plus b over x plus 1. Replace a by 5 over 2 and b by negative 3 over 2. And look what we have. That would be 5 over 2 times x plus 3 minus 3 over 2 times x plus 1. Now, what you should appreciate is that while it is difficult to integrate this left-hand side, it is very easy to integrate the right-hand side because we can integrate each of these simple expressions one by one. Alright, that's what we will do in this. Another one. Use partial fractions to evaluate integral 1 over 4x squared minus 9 dx. Well, what is the first thing to look for? The first thing to look for is, can you factor the denominator? Can you factor the denominator 4x squared minus 9? Well, you can. 4x squared minus 9 is 2x plus 3 times 2x minus 3. And so, the denominator is now the product of two linear factors. So this will be written as a over 2x plus 3 plus b over 2x minus 3. What is the next step? Simplify this by taking 2x plus 3 times 2x minus 3 as the common denominator and construct your numerator. What will the numerator be? It will be a times 2x minus 3 plus b times 2x plus 3. There you go. So you have constructed the numerator and we have the common denominator. And if you look, this 4x squared minus 9, the denominator on the left side, is exactly the same as the denominator on the right side. That means the numerator on the left must be equal to the numerator on the right. Alright? So equating the numerators of the left-hand side and the right-hand side, what do we get? 1 equal to a times 2x minus 3 plus b times 2x plus 3. Alright, what's the next step? Our aim is to find the values of a and b. That means find appropriate values of x. This is an identity. Find appropriate values of x that will reduce either a to 0 or b to 0 so that we can... Alright. Now a can be eliminated by, tell me, I'm covering that value here. A can be eliminated by choosing x equal to what? If you put x equal to 3 over 2, then 2 times 3 over 2 will be 3. 3 minus 3 will be 0. So we set x equal to 3 over 2 in here so that we can eliminate x. You see how simple that is. So we get 1 equal to a times 2x become 2 times 3 over 2 minus 3 plus b times, remember every x need to be replaced by whatever we choose. So that will be b times 2 times 3 over 2 plus 3, and that will eliminate this. Is that right? And this will be 3 plus 3, 6b. We got 1 equal to 6b, 1 on the left hand side, and the right hand side, this will become 0. This will be 2 and 2 goes, 3 plus 3 is 6. So 1 equal to 6b, or b equal to 1 over 6. Similarly, we go and eliminate b. Tell me, what will you choose as x equal to eliminate b? What value of x will make this quantity 0? X equal to negative 3 over 2. That's right. Put x equal to negative 3 over 2. You have 1 equal to a times 2 times negative 3 over 2 minus 3 plus b times 2 times negative 3 over 2 plus 3. We just replaced x by negative 3 over 2. And if you notice here, the 2 and the 2 cancels. That will be negative 3 plus 3, 0. So that term will vanish. And this will be 2 and 2 goes. It will be negative 3 minus 3, negative 6a. You get 1 equal to negative 6a. And that gives you a equal to negative 1 over 6. So we can now take the values of a. What's a equal to? A is negative 1 over 6 and b is positive 1 over 6. Alright, let's write that down. So we have a over 2x plus 3 plus b over 2x minus 3 now become negative 1/6 over 2x plus 3 plus 1 over 6 over 2x minus 3. And that is, that negative sign will make that whole quantity negative. It'll be 1 over 6 times 2x plus 3 plus 1 over 6 times 2x minus 3. Now, this is what we need to integrate originally. Now, since it is difficult to integrate, we broke it down into simpler expressions. Alright, therefore we can now integrate this. Now, integral 1 over 4x squared minus 9 dx is now the same as integral of this. Now look at the way I wrote that. That's right, integral of this, which is the sum of two functions. Which means we can integrate each of them one by one. Alright, now the first thing I can do is I can factor out a negative 1/6. If I factor out a negative 1/6 from here, this will remain positive and that will become negative. Is that right? Yes. So if I factor out a negative 1/6, alright, we are not factoring out the 1/6. We just take out the negative 1/6 from here. We are going to split this into two integrals. So that will be, the first one will be negative 1/6 integral 1 over 2x plus 3 dx. That is the first integral. Plus 1 over 6 integral 1 over 2x minus 3 dx. Now you can see I have colored them red, the denominators, because these are simple expressions we can do by a substitution. Now look on the right side, see how the substitution is made. In the first integral, we replace 2x plus 3 equal to u. So when 2x plus 3 equal to u, take the differential of each term. Differential of 2x is 2 dx, differential of 3 is 0, differential of u is du. That gives you dx equal to du over 2. So when this is replaced as u, dx becomes du over 2. And this 2x minus 3, since we have already used the u, we will use 2x minus 3 as v. and that gives you 2 dx equal to dv, or dx equal to dv divided by 2. So when this becomes u, this dx becomes du over 2, and then this becomes v, the dx becomes dv over 2. There you go. And you can actually take these 2's out. This will become negative 1/12 1 over u du plus 1/12 integral dv over v. There you go. And you can integrate each of them. Integral 1 over u du is ln of u, and integral 1 over v dv is ln of v. So negative 1/12 ln of u plus 1/12 ln of v. Of course, it must be the absolute value. And plus c, well, that will be 1 over 12 ln v over u. Can you figure out how that came out? Well, you can take out a 1/12 outside, and the negative term will be ln u, negative ln u plus ln v. Remember, ln v minus ln u is ln of v over u. Ln of v over u is ln v minus ln u, and the 1/12 has come out. So it will be 1 over 12 ln v over u plus c, and all we need to do is replace v and u. So our final result is 1 over 12 ln 2x minus 3 all over 2x plus 3 plus c, and that is the integrated form of this rather complicated integral. You see how it became simple by breaking them down into partial fractions. Alright, let's do another one. Use partial fractions to evaluate integral 3x squared minus 7x minus 2 all over x cubed minus x. Alright, what's the first tip to do? First, we try and obtain the partial fraction decomposition of this complex expression. And what's the first thing to look for? The first thing to look for is, can you factor the denominator? Can you factor the denominator? First of all, you see a common factor there, x. So that will be x times x squared minus 1. And x squared minus 1 can further be factored as x minus 1 times x plus 1. There you go. So that would be 3x squared minus 7x minus 2 over x times x plus 1 times x minus 1. We have 3 linear factors. So how will you address that in rewriting it in the partial fraction form? You will write it as a over x plus b over x plus 1 plus c over x minus 1. You got 3 linear factors, so we use 3 constants. Okay, well, now the routine thing that we do. What's the routine thing? Take the common denominator, which will be x times x plus 1 times x minus 1, and then construct your numerator. Alright, tell me, how do you construct the numerator? What will x be multiplied by? X will be multiplied by all the factors on the denominator except the denominator of this. In other words, a will be multiplied by x plus 1 times x minus 1, plus b will be multiplied by x times x minus 1, right? Plus c will be multiplied by x times x plus 1. These skills you know already. So we will write it like this. This will be a times x plus 1 times x minus 1 plus b times x minus 1, bx times x minus 1 plus c times x plus 1. Okay, now I have put them in red colors so that you can see them a little more clearly. Alright, now the denominators, this denominator x cubed minus 3 is the same as this denominator, which means we can equate the numerators on the left and on the right. That gives you 3x squared minus 7x minus 2 is a times x plus 1 times x minus 1 plus bx times x minus 1 plus cx times x plus 1. Well, because we have three constants a, b and c, we need to reduce two of them to 0 if we want to find the third one. Can you find a way? Remember, this is an identity, which means you can use any value of x, any convenient value. Now, can you find a convenient value of x that will reduce two of these constants to 0, a, b and c? You need to reduce two of them to 0 to find the third one. Alright, what will that be? There are a couple of options. If you choose x equal to 1, this will go to 0 and this also will go to 0. Another option is if you choose x equal to 0. Look at that. X equal to 0 will reduce this to 0 and that to 0, and you can find a. That's the way to look for it. So let's set x equal to 0. That will eliminate b and c. We can find a. Let's do that. Set x equal to 0. That's the most convenient one. So that will make 0 minus 0 minus 2 equal to a times 0 plus 1 times 0 minus 1. Is that right? Replace all x's by 0. Plus this will become 0 and that will become 0. And what is then left over? The left hand side is negative 2. The right hand side is, look at this, this is plus 1, this is times negative 1. That will be negative 1 times a. Negative 2 equal to negative a, and that gives you a equal to 2. Very easily we got the value of a. Alright, let's go and find the other constants b and c. What will you do next? Well, if you put x equal to 1, it will reduce this term to 0 and this to 0. We can eliminate a and b and we can find c. So let's set x equal to 1. Replace all x by 1. 3 times 1 squared minus 7 times 1 minus 2 equal to a times 1 plus 1 times 1 minus 1. Is that right? That will go to 0. b times 1 times 1 minus 1 plus c times 1 plus 1. That will give me 3 minus 7 minus 2 on the left side. This is 0, this is 0, this is 1 plus 1 is 2 times c is 2c. And that gives you negative, this is negative 6, is that right? Negative 9 plus 3 is negative 6 equal to 2c, or c equal to negative 3. Well, once you have the values of two constants, then any x value will be alright because you know the values of two constants and we find the third one. Alright, let's set x equal to negative 1. Well, actually if you set x equal to negative 1, a will be eliminated, c also will be eliminated, we can find b. Alright, and that's what you have, and that will give you b equal to 4. Okay, that's not a big problem for you. Now you have the values of a equal to 2, b equal to 4, and c equal to 3. Therefore, let's write down what this expression is. So we have 3x squared minus 7x minus 2 all over x cubed minus x now becomes a over x, which is 2 over x plus b is 4 over x plus 1, and c is negative 3, will be minus 3 over x minus 1. Replace your a, b and c, and that's equal to, that minus will make this sign negative. Well, we can now integrate this. While integrating this quantity is very complex, integrating this will be very simple because we can integrate each of these terms separately. Alright, so integral of 3x squared minus 7x minus 2 over x cubed minus x is now the same as integral of that quantity, which you can break into individual integrals. That would be 2 integral 1 over x dx plus 4 integral 1 over x plus 1 dx minus 3 integral 1 over x minus 1 dx. Well, these actually do not need any substitution, does it? No, because integral 1 over x dx is ln of x. Integral 1 over x plus 1 dx is ln x plus 1, absolute value of x plus 1, and same here. So that will be 2 ln x plus 4 ln x plus 1 minus 3 ln x minus 1 plus c. And 2 ln x is ln of x squared. 4 ln x plus 1 is ln of quantity x plus 1 to the power of 4. And minus 3 ln x minus 1 is minus ln x minus 1 quantity raised to the power of 3. There you are. And this can be combined into one ln quantity. How is that? Now these two are positive. That means they will get multiplied and this will go to the denominator. Is that right? So this will be ln of x squared times this quantity divided by that quantity. There you go. So that's equal to ln x squared times x plus 1 to the power of 4 all over x minus 3 to the power of 3 plus c is that integral. You can see by breaking down into these partial fractions we were able to integrate it without any pain. Very simple form of integration. Alright, let's do another one. Use partial fractions to evaluate integral 2x minus 3 divided by x minus 1 all to the power of 2. What do you notice here? Well, the denominator is the second power of a linear factor. And how do we deal with that? How do we deal with that? This will be a over x minus 1 plus b over x minus 1 to the power of 2. That's right. Okay, now how do we take the common denominator and simplify this? Our common denominator is x minus 1 to the power of 2. Right? And what will a get multiplied? There is an x minus 1 already on its denominator, therefore a will get multiplied by an x minus 1 and b will get multiplied by 1. That's right. So that will be a times x minus 1 plus b all over x minus 1 raised to the power of 2. I hope you know these skills very well by now. Well, now the two denominators are the same, the left hand side and the right hand side. That means the numerators can be equated. What do we have? We got 2x minus 3 equal to a times x minus 1 plus b. Okay, what do we do? Eliminate one of them. If you choose x equal to 1, that term will get eliminated. So x equal to 1 will eliminate a and give you the value of b. So let's do that. Replace x by 1. That will be 2 times 1 minus 3 equal to a times 1 minus 1 plus b. So that goes, and 2 minus 3 is negative 1. We get b equal to negative 1. Well, we cannot eliminate b using any x value because b has no x associated with it. That means you can choose another x value here and then replace replace b by -1, and then find the value of a. So let's put x equal to 2 then. If x equal to 2, what will you get? 2 times 2 minus 3 equal to a times 2 minus 1 plus b. And replace your b by -1 at some time so that we can find your a. Now this will give you a plus b equal to 1, isn't it? 2 minus 1 is 1. A plus b equal to 4 minus 3 is 1. A plus b equal to 1. But b equal to -1. Therefore, a plus b, a plus -1 equal to 1. That gives you a equal to 2. So you have the values of a and b. We can now go and replace them. Therefore, our right-hand side will now become 2 over x minus 1 minus 1 over x minus 1 all squared. And instead of integrating the left-hand side, we can now integrate the right-hand side. So integral 2x minus 3 over x minus 1 all squared dx can now be written as integral 2 over x minus 1 minus 1 over x minus 1 all squared dx. And let's do that. Let's replace x minus 1 by u. When x minus 1 becomes u, x minus 1 to the power of 2 becomes u squared, and dx becomes du. So x minus 1 equal to u, dx equal to du. That becomes integral 2 over u minus 1 over u squared du. Alright, tell me, what is integral of 2 over u? Is 2 times integral 1 over u du. That would be ln of u. And let me see how many of you remembers this. What is integral of -1 over u squared du? Now remember, the derivative of 1 over x is -1 over x squared. So integral -1 over x squared dx will be 1 over x. Integral -1 over u squared du will be 1 over u. Alright? So this will be 2 ln of u minus, well, I did it in 2 steps, minus integral of 1 over u squared du is -1 over u, and combining these two will become positive. So that will be ln 2 ln u is ln of u squared. This is plus 1 over u plus c. And what do you do next? Replace your u. That will be ln of x minus 1 to the power of 2 plus 1 over x minus 1 plus c. So if you cannot see this, I'm going to read this one more time. The final result will be ln of x u squared is x minus 1 to the power of 2 plus 1 over u is 1 over x minus 1 plus c. And that is the result of integrating this complex quantity. All right. Right, let's try another one. Evaluate the integral using partial fractions. Integral x over x cubed minus 1 dx. Well, to start with, we obtain the partial fraction decomposition of the quantity that we want to integrate. All right, tell me, how do you break this down into partial fractions? The denominator is x cubed minus 1. Well, x cubed minus 1 can be factored. Now, how do you explain or expand a cubed minus b cubed? A cubed minus b cubed is a minus b times a squared plus ab plus b squared. Is that right? Now this is a cube minus b cube form. X cube minus 1 is x minus 1 times x squared plus x plus 1. Right? Yes. So x cubed minus 1 is x minus 1 times x squared plus x plus 1. We have a linear factor and a quadratic factor. Now how do we deal with it? It will be a over x minus 1 plus, how do you accommodate the quadratic factor? It will be plus bx plus c over x squared plus x plus 1. So there you have a over x minus 1 plus bx plus c over the quadratic factor. Well, now we proceed as usual. Take the common denominator and simplify. And that will be, common denominator is x minus 1 times x squared plus x plus 1. And a gets multiplied by the quadratic factor. And bx plus c, the quantity bx plus c, gets multiplied by x minus 1. And we now have the denominator on the left equal to denominator on the right. Therefore, the numerator on the left must be equal to the numerator on the right. And there you have. And our aim now is to choose appropriate values of x, to reduce two of the constants to 0 and find the value of the next one. Well, this is not as simple as the ones we have been doing. So we start by setting x equal to 1, and x equal to 1 will eliminate b and c. Is that right? Yes, because x equal to 1 will make this 0, and that means that will eliminate the whole of that. We can find a. All right, let's replace x by 1 in the identity. That will be 1 equal to a times 1 squared plus 1 plus 1 plus b times 1 plus c, bx plus c, times 1 minus 1. That will eliminate this. And what is inside here is 1 plus 1 plus 1, 3. We get 1 equal to 3a. There you go. Or a equal to 1/3. So we found the value of a. Now we need to find b and c. What do? To find b and c, we assign other values to x. You see, if you can find the two equations, we can solve for b and c. So let's see what we can do. Let's first of all start with x equal to 0. Remember, you can choose any value of x. It will be true, the identity is true for all values of x. X equal to 0 is a very convenient value. So let's replace x everywhere by 0. That gives you 0 equal to a times 0 plus 0 plus 1 plus b times 0 plus c times 0 minus 1. Now, what do these things amount to? This will be 1a, that will be a, and b will go, and this will be 0 minus 1, negative 1 times c. So the right side will be a minus c. Is that right? Yes. A minus c equal to 0 gives you a equal to c. If a minus c equal to 0, it means a equal to c. Since we know a, we also know c. A equal to 1/3, therefore c is also 1/3. Now that you know the values of a and c, you assign any other values to x and replace a and c, we can find the value of b. So let's say set x equal to 2. And that will give you 2 equal to a times 2 squared plus 2 plus 1. Plus bx plus c is b times 2 plus c times 2 minus 1. And that gives you, this will be 4 plus 2, 6 plus 1, 7. 7a plus 2b, is that right? Now 2 minus 1 is 1, so there will be 2b plus c. Now 2 equal to 7a plus 2b plus c, but you know the values of a and c. A equal to 1/3 and c equal to 1/3. And therefore you get 2 equal to 7 times 1/3 plus 2b plus 1/3. And you can simplify that. We get 2b equal to 2 minus 7/3 minus 1/3. And that will give you b equal to negative 1/3. Now try it on your own. That's not very difficult. So I will give you the value of b, negative 1/3. So a equal to 1/3, c equal to 1/3, and b equal to negative 1/3. We can go and rewrite this expression in order to integrate it. So that will be integral x over x cubed minus 1, the left hand side, I know you cannot see it well, equal to integral of this quantity where we replace a, b and c. Will be integral a over x minus 1, a is 1/3, plus bx plus c, b is negative 1/3, plus c is 1/3. So we just replaced a, b and c. Now how does that change? You can see, you can break it down into individual integrals. This will be 1/3 integral 1 over x minus 1 dx, that is the first term. And in the second term, we factor out a negative 1/3. Now remember, when a negative 1/3 is factored out from here, this x will remain positive and this will become negative 1, because 1/3 times negative 1 is negative 1/3. We factor that out. So negative 1/3 comes out. You have integral, what's remaining there is x minus 1 over x squared plus x plus 1 dx. Okay, now what do we do? The first integral is the standard integral, is that right? No problem. 1/3 integral 1 over x minus 1 dx is 1/3 ln absolute value of x minus 1 plus c. That's simple. But the second one is not very simple. Now, to evaluate the second integral, knowing that the derivative of x squared plus x plus 1 is 2x plus 1, we attempt to introduce 2x plus 1 on the numerator. Now, is it possible to write x minus 1 using 2x plus 1? Oh, well. First of all, look at this. X minus 1 can be written as 1/2 of 2x plus 1 minus 3. Is that possible? Well, you can see plus 1 minus 3 is minus 2. So 2x minus 2 is 2 times x minus 1. And the 2 will cancel. So look at the ingenious way that we are going to introduce the quantity 2x plus 1 on the numerator. Why are we doing this? Because the derivative of the denominator is 2x plus 1. If we have a 2x plus 1 on the numerator, we can make a substitution for the denominator as u. Now remember, when you make a quantity equal to u, we need to replace our dx in terms of u. That means you need to have a quantity on the numerator which contains the derivative of that denominator. That's the reason why we are doing that. So we're going to write x minus 1 equal to 1/2 times 2x plus 1 minus 3. Now, what change does it bring it there? And that will be 1/2 of 2x plus 1 minus 3 over 2. Is that right? Split into 2. Now, that will make it much easier when you write it. So, integral x over x cubed minus 1 now becomes the numerator x minus 1 is going to be replaced by this quantity. That's interesting. This is already we know, so we are leaving it like this. It is the second integral that we are interested in. So in the second integral, the numerator x minus 1 is replaced by this quantity. There you go. Okay, now we are back with this. We need to still fight with it. It's not easy yet. So we don't touch this. This is something that we can integrate. But the second integral, look at the numerator. The numerator is this quantity minus 3 over 2, which means we can split this into two integrals. So the first integral will have that as the numerator. And when you take that as the numerator, 1/2 comes out, gives you a negative 1/6. So that will be negative 1/6 integral 2x plus 1 over x squared plus x plus 1. Do you understand that? What I have done is I split this into two integrals. The first one is integration of this quantity divided by this. And when you do that, take out that 1/2, which gets multiplied by 1/3, gives you 1/6, leaving you 2x plus 1 on the numerator, and the denominator is this. Plus, the second one is, why have this become plus? This is minus, this is minus, this negative 3 over 2 comes out, multiplies by negative 1/3, making it a 1/3, is that right? Well, we did not take out the 3 over 2, we left that 3 over 2 there. We only took out that negative. That negative with the negative become positive, and this now become positive 1/3 integral 3 over 2 over x squared plus x plus 1. I want you to look at this and learn that skill. We split this into two integrals. One is integral of 1/2 2x plus 1 over this. The next one is integral negative 3 over 2 over this. And the first one simplified to this. The second one, the negative become positive, simplified to that. But now, this can be integrated easily. How? If you put x squared plus x plus 1 equal to u, then 2x plus 1 dx becomes your du, because 2x plus 1 is the derivative of this. Alright, now we're going to make a substitution. Substitute x minus 1 equal to u here, and substitute x squared plus 1 plus x squared plus x plus 1 equal to u here. We're going to use u right through. They are not the same u, they are different u's. So this is our first u, this is our second u, and what we need to do here is complete square here. Well, you know how to complete square, don't you? Now look at the number of skills involved in here. So let's complete square. X squared plus x plus 1. In order to complete square, what we need to do is take the coefficient of the middle term, that is 1, take half of that, that is 1/2, and square it, that is 1/4. So x squared plus x plus 1/4 is a perfect square. Now 1 can be written as 1/4 plus 3/4. So look at this. It'll be x squared plus x plus 1/4 is 1/2 to the power of 2. So this is x squared plus x plus 1/4. And what is left of that 1 is now 3/4. Now how do you write this one now? This is a perfect square. This is x plus 1/2 all to the power of 2. That's right. So x plus 1 all to the power of 2. And 3/4 can be written as square root 3 over 2 all to the power of 2. Now tell me, why are we doing all these acrobatics? Well, in order to integrate this, what we are trying to do is to break this down in the form u squared plus a squared. And this is our u, And this is our a. So it becomes u squared plus a squared form, so that the integral becomes what form? Is it arcsine, arcsecant, or arctan? We are driving towards making this integral of the arctan form. That's right. Okay, so now let's write all this together. Integral x over x cubed minus 1 is 1/3 1 over 1 minus 1 over x minus 1 dx minus 1 over 6 of this plus 3 over 6. We left all this there, and we just deal with that denominator. What did that denominator become? And also you noticed one thing. I took out that 3 over 2 and I wrote the constant as 3 over 6. So the numerator now is 1 there. And the denominator is x plus 1/2 all squared plus square root 3 over 2 all squared. This is of the form u squared plus a squared. Now we can go and do these substitutions and call this also equal to another u. Okay, now we have, let's say, that x minus 1 equal to, when this x minus 1 equal to u, dx becomes du. And when x squared plus x plus 1 equal to u, then 2x plus 1 dx equal to dv. Well, let's call it uv and so on. And x plus 1/2 equal to w. So instead of calling them all u, as I said earlier, let's call this u, this v, and this w. So this x plus 1/2 becomes w. We get dx equal to dw. Alright, take all these substitutions in here. What does our integral become? It'll be 1/3 integral 1 over u du minus 1/6 integral 1 over v dv. 2x plus 1 dx is now your dv, plus 1/2 1 over w squared plus root 3 over 2 all squared dw. All these can be integrated. This is the ln form, this is the ln form, this is the arctan form. What is integral of 1 over u squared plus a squared du? It'll be 1 over a arctan u over a. In our case, that u is w. Alright, so this will be 1/3 ln u, absolute value, minus 1/6 ln v plus 1/2 times, this is arctan form, 1 over a. 1 over a is 2 over root 3, arctan u over a, w over root 3 over 2. And our next step, we replace u, v, and w. That gives you u is replaced by x minus 1, v is replaced by x squared plus x plus 1, and w is replaced by x plus 1/2. And one more thing, 1/3 ln x minus 1 is ln of x minus 1 to the power of 3. Is that right? But we can make that change in there. This can be written as ln x minus 1 to the power of 1/3. Well, I think it is better left it like this, rather than raising it to the power of 1/3 and 1/6. So this will be now, look at the way I simplify this, arctan. This is 2x plus 1 over 2, and that 2 will come the denominator. 2 times 3 over 2 will be square root 3. Now that will be, therefore, this will be square root of 3. That's right. That 2 will cancel, but this will remain a square root of 3. And we had a 3 on the numerator. I want you to look at this simplification one more time, how this got simplified. Now, if you notice, this will be your w over a, root 3 divided by 2. That divided by 2, that 2 will go up, When you expand it, it'll be 2x plus 1. That's how the 2x plus 1 comes in there. So it will be 2x plus 1 divided by root 3, and rationalize it by multiplying numerator and denominator by root 3. It'll become, the denominator now become root 3 times root 3, and the root 3 will go on the numerator. So that will be arctan root 3 times 2x plus 1 over 3 plus c. Now this is an extremely important type because it involves a lot of these skills, and it is nice that you practice this. Now finally, let's try this. Evaluate the definite integral, integral 1 to 5 x minus 1 over x squared plus x plus 1 dx. Well, let's take the quantity for integration and obtain the partial fraction decomposition. Alright, tell me, what about this denominator? What kind of denominator is it, and how do we break it down into partial fractions? X squared is x times x, is that right? That's right. So it will be, it is the power of a linear factor, the second power of a linear factor. So we could write it as a over x plus b over x squared plus x plus 1 is the linear factor, that will be c over x plus 1. There you go. So this will be a over x plus b over x squared plus c over x plus 1. And take the common denominator. Common denominator is x squared times x plus 1. Tell me, what will a get multiplied? The common denominator is x squared plus x plus 1. A will get multiplied by x times x plus 1 because there is an x already there. B will get multiplied by x plus 1, and c will get multiplied by x squared. Alright, so that will be ax times x plus 1 plus b times x plus 1 plus cx squared over x squared times x plus 1. And now we have the numerator on the left equal to the numerator on the right, and this is what we have. Well, if you look closely, this is very simple. We can eliminate a and c by choosing x equal to what? X equal to 0. We can eliminate a and b by choosing x equal to -1. So that's very simple. Let's set x equal to 0 so that we eliminate a and c. It will give you 0 minus 1 equal to a times 0 times 0 plus 1 plus b times 0 plus 1 plus c times 0 squared. And that will give you, I'm going to leave now for you to figure out the simplification. Well, of course, that will go, this is b, and that gives you b equal to -1. That's right. Okay, next let's use x equal to -1, and we have -1 minus 1 equal to a times -1 times -1 plus 1 plus b times -1 plus 1 plus c times -1 all squared. Now solve that, what will you get? We have a eliminated, b eliminated, we will get -1 squared is 1, 1c equal to -2 or c equal to -2. We got the values of b and c, we now need the value of a. Let's do that. Well, let's set x equal to 1 there. X equal to 1 will give me 1 minus 1 equal to a times 1 times 1 plus 1 plus b times 1 plus 1 plus c times 1 squared. And what will that give you? It will be, the left hand side is 0. On the right, 1 plus 1 is 2. That will be 2a plus 2b plus c. That's right. So 0 equal to 2a plus 2b plus c, and b equal to -1, c equal to -2, and therefore we find A. That will be, we get 2A equal to negative 2 times negative 1 minus negative 2. I wrote 2A equal to negative 2B minus C. Negative 2B minus C. B is negative 1, C is negative 2. And that gives you A equal to 2. And bring all those values, what will this expression now become? It will become A over X, where A equal to 2, plus B over X squared, where B equal to negative 1, and C equal to negative 2. That will be 2 over X minus 1 over X squared minus 2 over X plus 1. And we can now integrate this. I'm sure if I ask you to integrate each of these, there will be no trouble doing that. Alright, let me ask you, what is integral of negative 1 over X squared dx? Integral negative 1 over X squared dx is 1 over X, because the derivative of 1 over X is negative 1 over X squared. Alright, so integral 1 to 5 of x minus 1 divided by x squared times x plus 1 dx is now integral 1 to 5 of the right hand side. We can now integrate each of these without any trouble. Well, integral of 2 over x will be 2 ln x, and minus, you can see I have used two negatives there, minus integral 1 over x squared is negative 1 over x, and minus 2 times integral 2 over x plus 1 is 2 ln x plus 1, and the limit is from 1 to 5. And what we do is first use the upper limit, replace x by 5. That will be 2 ln 5 plus 1 over 5. That will be, these two negatives become plus 1 over 5 minus 2 ln 5 plus 1. This is the upper limit. Minus, now replace x by 1, 2 ln 1 plus 1 minus 2 ln 1 plus 1. Okay, let's take it over to the other side. Now this is what we had, and what would that become? It will be 2 ln 5 is ln of 5 squared plus 1 over 5, and this is ln 6. 2 ln 6 is ln of 6 squared. Now that is your upper limit. Now minus what you have with the lower limit, ln 1 is 0 plus 1 minus, you see, ln of 1 plus 1, ln 2, and this will go up. That will be minus ln 2 squared, and that will be ln 25 plus 1 over 5 minus ln 36 minus 1 plus ln 4, and that can be evaluated on the calculator. Is that right? Or look at this again, ln 25 plus ln 4 minus ln 36. Use the ln properties. These are two positive values, this is negative, so that will be ln of 25 times 4 divided by 36. That's right. Minus, this is plus 1/5 minus 1 is minus 4/5. And that will be ln of 25 minus 9 minus 4/5. This is the exact value of that integral. And it's always desirable to leave the expression as an exact value. Okay, well, I said this is the last one. Let me leave you with one to be done on your own. Try this on your own. Integral 0 to 1, x minus 2 over x squared plus 4x plus 3. Now, if you notice, I'll give you a clue. This is very simple. This is something that we actually done earlier. X squared plus 4x plus 3 can be factored. You have two linear factors. What are they? X plus 3 times x plus 1. Alright, try it on your own and let me know how it is.